All right, so I hope it's recording. It didn't beep. I don't know. Usually it beeps when it tells me that I'm recording. Now, I think I'm up over in this corner now. I think I'm in the upper right instead of the lower right. Ooh, changing it up on you a little bit. I didn't want to block stuff over here that I wanted to point to and reference. So anyway, we had just gotten to where we were finishing this graph on whatever day, the last day you were here. So Thursday or Friday, depending on what period you are. And I was working in class to kind of show you how the slope thing works, which again, there's a video about that. If you missed that video, watch that. That was posted on either Thursday or Friday, depending on your class period. And so, reminder, we found the rise, at least I did, because I went by threes on my interval. So 3, 6, 9, 12, 15. So I had a 15-meter rise here. And again, I know it's 15 meters because it's height of the building measured in meters. And I found out I had a 5.5 story run because I did go by ones down here. And so each box, I got a 1, 2, 3, 4, 5 and a half. And so that was my 5.5 stories. Now, rise over run is what we call slope. And so that was 15 meters over 5.5 stories. And then you divide that, and I got 2.73. The unit of measure is the tricky part because they don't just go away. They have to stay. So meters on the top, stories on the bottom. And so that's exactly how it stays. You divided the numbers, and so we also divide the unit. Now, you obviously can't divide a meter by story and get some thing. It stays as meters divided by stories. Now, the question becomes, what does that mean? What is this telling us about this particular graph? And so I hope that you're kind of seeing this. And some people in some of the classes said, well, I think that means that there's 2.73 meters per story. Well, yeah, that's what that means. It means that's about how tall, how much height you're going to get for every story that the building is. Now, notice I said a different phrase than per. I said for every. Because the slope thing here, it's a ratio. If we were to say this out in a sentence, here's how it might look. And so this is what we did in class. We wrote this out as a sentence. And it says there are 2.73 meters of height for every one story. About 2.73 meters of height for every one story. That's what this data is telling us about how the height is related to how many stories the building has. Now, I went on and wrote some other things down. That slope is a ratio. And in this case, for me, it's a 2.73 to 1 ratio. See, we don't keep it in this form. We don't keep it in the 15.5 or 15 meters to 5.5 stories. We don't keep it there. We actually divide it so we can get it down to a something to 1. It needs to be a something to 1 ratio. So we simplify the ratio down, and this is what we get. And it's telling us about the relationship between the variables. Again, the fact that there's 2.73 meters of height for every one story that the building is tall. Again, it's a ratio, and it tells us about the relationship. Now, this is also straight line data, which we call linear, and that's also called directly proportional, right? Directly proportional relationship. That's what linear is. So when you see data on a graph and it looks like the data is a straight line, this is what it means. We call it linear, first of all. Second of all, it is telling us that those two variables, in this case, building height and number of stories, those variables are directly proportional to each other. And what exactly does that mean? Well, that means that they have a constant ratio or a constant slope. What's the ratio? Well, for me, it's a 2.73 to 1. I'm hoping that all of you, when you did this, when you found your slope, that you were somewhere between 2.5 and 3.5 meters for every one story. Between 2.5 and 3.5 meters for every one story should be about where you ended up. Now, again, not everybody's going to have exactly the same slope because, as we said the other day, you had to guess where to put your data points. You had to guess where to put your best fit. You had to guess when you picked your 2 points to find the slope, you had to guess where those were and what the values were that you picked. So there's a lot of guessing involved, and that's why not everyone is going to have the same exact slope. So anyway, that is what we just kind of finished up. And then we went to this set of data. Let me lock this down. Hold on. Control. So this is a different set of data, and this is the page 2 of the worksheet that was posted. I'm not sure when that was. That was last week. I can't remember what day, but it is Unit 1.2 Graphing Applications Worksheet 1, I believe, which is on Classroom. The same document that the building height and stories, the data we just looked at, same worksheet, but the first page. This is the second page. Now, you're going to put this into a graph form as well. This one I don't think is quite as obvious as to which one is manipulative and which one is responsive. So I'm just going to tell you. I'm going to write this up here. Hopefully this thing is actually still working. Oh boy. So number of classes is manipulative. Number of classes is manipulative. So in other words, the school is going to decide how many classes of science are available. And then the number of students taking those classes is going to respond or be responsive to the number of classes available. So that's how I just made the call and said, okay, this is how we're going to do it. The school is going to determine and make the decision. They're going to manipulate how many classes they're going to offer because they only have so many teachers and there's only so many periods in the day. And so they can only offer science so many times. And then the number of students that can take science is going to then depend on how many classes are available. Hopefully that makes sense. Now, at this point, that should tell you which of these variables goes where on the graph. Now, if I were you, if you weren't here when we did this, then if I were you, I would pause the video right now and then try to set this up. Because now that you know that responsive is the number of students and that manipulative is the number of classes, that tells you where they belong on the graph. So where they belong, you know that now based on those. And you may think, well, you didn't tell us that. Yes, in your comp books, you should have written down at some point that the manipulative always goes on one of the axes, and then the responsive, had a mental lapse there for a moment, and the responsive goes on the other one of those two axes. So if you can't remember that, I would look that up in your comp book and then proceed with setting up your graph. And then tune back in, and then I'll set it up, and then we'll draw best fit, find a slope, all that stuff. So come back when that's done. Oh no, this is going to be interesting. Now I have to do this, and that's going to make this video kind of long. Oh no. Oh no. Oh my gosh. This is not working. Oh, there we go. Get out of here. There we go. Okay, finally got some room. Now, let's see. That means number of classes of science is down here. Number of students is here. And in terms of the interval, I'm going to go by halves, which means I can skip boxes and write only the whole numbers. And that fits because 9 is my max value there. And then for the vertical axis, for number of students, I could go by 20, so 10. Let's see, 40, 60, 80, 100, 120, 140, 160, 180, 200. Oh boy, keep going. Oh boy, keep going. 220, 240, 260, 280, 300, 320. There we go. Okay, then I gotta plot the data. Oh boy, let's see. I have 4, 126, 4, 126. I should have had this done already, so you wouldn't have to watch me do this. But I guess if you're having issues, and you tried to do this, and now you're finding out, oh, I didn't do it right. Now here, let's see. So that's 20. 30 would be halfway between 20 and 40, and so I'm halfway between the halfway between. So this data point should be, or in other words, a fourth of the way down, or 3/4 of the way up. Because again, every fourth, so that's 20, that's 25, 30, 35, and then 40 right there. So you're breaking them down into 4 parts if you went by 20s. Now you didn't have to go by 20s, but I did. And let's see, 8, 265, 8, 265, that is 260 right there, 270 up here, that means 265 is probably about like that. And 5, 166, 5, 160 is right here, 170 is right here, so a little over halfway up between 160 and 170, and 9, 290. Yeah, 9, 290, that would be, I wonder if I'm blocking, I wonder if my face is blocking this. So 280, I'll bring it up further. 280 is right, oh no, which one's 9? Okay. 280 is right here, 300 right here, and so 290 is right smack dab in the middle, like that. All right, now, hopefully when you look at this graph, you see that this is linear. This is not curved data. I would say this is linear. And so then I'm going to put my straight edge on here, because I can. Let me slide this down some. I'll put my straight edge on here. And as I draw my straight edge, I'm going to make it so, again, it is parallel to the data. Now, I probably drew it a little close. If I back that away a little bit, to me, that looks pretty parallel. I'm looking at the gap. I'm looking at the gap between the data points and the line, and that looks similar. This one's a little closer, but then this one's further away. And again, this one's a little closer over here as well. It's probably being hidden by my face in the corner. I don't know. So I think those look pretty good. Now, again, this would be like you putting your ruler beside your data so that it's parallel to it. Then you can slide your ruler over, over the data so that it is right over where the data points are. Now, if you look at what I have here, I think this is a good best fit, because it's not like getting further away from the data points or getting closer to some data points. This one's a little bit above, this one's a little bit below, this one's a little bit above, this one's a little bit above, this one's a little bit below. So it literally slices right down through the center of where my data is. And it just so happens, oddly enough, that this one goes perfectly through the origin, unlike the last graph. That last graph with the building height and all that stuff, that did not go through the origin very well. Let's see, where is that? Oh, I can't even find it. Is this even it? That's not it. Is this it? That's not it. I don't know where it is. Is this it? Yeah, look at that. That does not even go through the origin. That's like 2. If that's 3, then that's like almost 2, maybe more. So anyway, definitely not through the origin. This one, that's pretty good. Now I got to find my points for my slope. So I'm looking for places on my grid where my line hits perfect grid intersections, because I like perfect grid intersections. Ooh, this is a good one right here. I think that right there is a good one. Now, I'm going to move it so you can look and see. Do you see how that is right at a grid intersection? I think that's a good one. And I see another one. Right here is another one. Right there, it's perfect. Perfect grid intersection. Now, if you don't have any of those, then again, I would go like a spot like this might be good, because you're about in the middle of that box, and that would mean you're at like 50, right? but then you're on this line, which is like 1.5. So that might not be a bad spot to get. Now, I'm going to drop that down. I'm going to extend this over. And now I need to count out my rise and my run to get my slope. Now, remember, I said that I was going by 20s. My interval is 20s on my student's axis. That means when I count these boxes like this, it's not just 1, 2, 3, 4, 5. Okay, I have to count by 20s because my interval is 20s. The value of each of my boxes is 20. So I have to count 20, 40, 60, 80, 100. Okay, so my rise is 100 students. Oops, that's a T in this. And for my run, I went by half. Each box is worth a half. Half, 1, 1.5, 2, 2.5, 3. You get it. So half, 1, 1.5, 2, 2.5, 3. So I am three classes here. So 3 classes is my run, 100 students is my rise. And so when I find my slope, I have 100 students over 3 classes. And that equals, well, what's 100 divided by 3? Well, 33 1/3, right? So 33.3 we'll call it. 33.3. Now, oh, I put that over too far. I got to drag this over. Now, the unit of measure. I still need a unit of measure, all right? I need a unit of measure because a number without it just has no meaning. And whatever I did to the numbers, I do the same thing to the units of measure. So this, so this students and classes, those things don't go away. So we would actually write students slash class. Class. Now notice, it went singular. Here it was plural, classes. Now it's just class because we made it into a ratio of something to 1, right? Something to 1. So how would we write this out in a sentence? How would this be written out in a sentence? I want you to do that. If you haven't already done it, do that in your comment book and pause it and then come back and look at how I actually write it. Do that. Pause it. Oh, come on. There we go. So it means there are 33.3 students for every. That's what the slash means. You could say per. I like for every. For every one science, oh my goodness, science class. So that is how you write out this slope in a sentence to show its meaning, okay? There are 33.3 students for every one science class. That's what this tells us. That is the relationship between number of students and the number of science classes, right? That's how this works. I know I kind of flew through that, but hopefully it makes sense. So what you're going to do next, I have posted on Classroom an assignment, and it is a worksheet. It's a Word document that hopefully it opens as a Google Doc or something for you, and it doesn't screw up the formatting. But there is a description of an experiment. There is data there. You're going to have to, by reading the description of the experiment, you're going to have to actually determine which variable is manipulative and that the person is changing and deciding on, and which one is responsive, which one is changing because of what the experimenter did. So you're going to have to determine which one of those is which, and therefore which one goes on which axis, and then create the graph. and then answer a few questions about the graph. I've written that there's directions, exactly what you're supposed to do. You will put all this in your comp book and take a photo and upload it like we have the last 2 assignments. So that is for the next class period that you have. Again, you'll see it on Classroom. So hopefully, if you're not here, you're well and you're able to follow along and keep up with what we're doing. So if you have any questions, though, I would send me an email and I'll get back with you as soon as I can. Stay safe.